Number 10, the graph of f prime of t is given below. Note this graph is of the derivative of f, not of f itself. Find the integral from 0 to 4 f prime of t dt as accurately as possible. So if you're given the graph of some function and you want to integrate or find the definite integral of that function, that means area between the curve and the x-axis. So we're trying to find areas between 0 and 4 and the x-axis. So the first area is this piece up here, and then the next area is this piece here. It's always between the curve and the x-axis. And then the final area is that piece. And it says as accurately as possible. Now we might be tempted to do like rectangles, like approximations, and you would if this were a curvy thing, and you might be asked to do that using rectangles to approximate. But this one says as accurately as possible, and these are triangles. And so we can find the area of these triangles. So the area of the blue, half base times height, half of 1 times 2, which is 1. The area of the red, again, half base times height. The base here is 2, height is 1. So that area is also 1. And then finally the purple, half of base times height, half of 1 times 1, which is 1. And then we'll finally put it all together and say that the value of this integral, and by the way, the fact that this is the derivative of some function and not the function and not that function f itself makes no difference here. We're just doing area under the curve. Okay, so we got the area of the blue one, which is 1. The area of the red one is below the x-axis, so it becomes negative. And then the area of the purple, it's above, it's positive. So this integral is equal to a half. Part B, if f of 4 is 2, find f of 0. Okay, now we got to go back to the fundamental theorem, which tells us that the integral from 0 to 4 of f prime of t dt is equal to, so this is just the pattern of the fundamental theorem, it's f of 4 minus f of 0. Top minus bottom for not f prime, but for the original function f. And the reason that we pick 0 and 4, hopefully will become obvious in this next step. The integral from 0 to 4 is the number we just found up above. That's a half. Equals f of 4, that's given. It's 2 minus f of 0, that's what I'm trying to find. So the reason that we pick 0 and 4 is that we were given information about 4 and we wanted information about 0. So we can solve this equation down here at the bottom for f of 0 and get f of 0 is 1.5.